Example 2. Use the given function value and trigonometric identity to find the exact value of each indicated trigonometric function. So we're going to be taking some of them. Okay, so you're going to do A as classwork, B. Okay, let's do B and C. So you do classwork 1, classwork 2. So we're going to take B and C as one of our example. So remember what we have here is sec theta, right? Sec theta equals to 5. Okay, and you know that sec theta is 1 over cos theta, which is equals to 5. If we turn it upside down, we have cos theta equals to 1 over 5. So let's see what we can do from here. So our cot theta, B cot theta, I just ended up helping you with your assignment. No mark again, okay? So cot theta is what is cot theta? Do we have an identity that involves that uses cot theta and the other one? Cot theta is a cos theta over that. Yeah, good. So to find the cot theta, we have one of our identity that says 1 plus cos square theta equal to cosec square theta. Okay, that was cosec, so we can't use that one. So since it is cosec, we can't use that one. Let's use the one from tan. If we use the one from tan, we only have sec. Okay, let's use the one from tan. Tan square theta plus 1 equals to sec square theta. Okay, so tan square theta, that will be 1 over cot square theta, right? Okay, let's just leave it like that. So we know that this value is this, so sec square theta, that would be 5 squared. So tan square theta plus 1 equals to 5 squared, because sec theta is 5, so and that will be 25. So therefore tan square theta equals to 25 minus 1, which is 24. So if we take the square root of both sides, we have square root of tan theta all squared equals to plus or minus square root of 24. So what quadrant are the angles? Use the given function value and trigonometric identity to find the exact value of each indicated function. So the quadrant is not given, so we are going to leave it like this. So this means that tan theta square cancel square root, tan theta equals to plus or minus, this will be 4 times 6, right? That is 2 root 6. Okay, so this is tan theta, and then you know that our cot theta equals to 1 over tan theta. That would be 1 plus or minus 1 over 2 root 6. So we have to rationalize. That would be plus or minus 1 over 2 root 6 multiplied by root 6 all over root 6, and that would be equals to plus or minus or root 6 over what? Over 12. 2 times 6 is 12, and that is the answer. Okay, so C, cot 90 minus theta. So this is one of the co-function identity. We've not done co-function, but we can quickly do that. So cot 90 minus theta, we're looking for cot 90 minus theta. So in one of the co-function identity, cot 90 minus theta is equal to tan theta. Okay, so cot 90 minus theta is equal to tan theta in a co-function identity. Let's see if I can quickly get a value and show you what we have there. So yeah, okay, so this is not here, so this is not a co-function identity. Let me see if I can quickly show you the code. Okay, not here. Okay, So we're just going to leave it like that. So let's solve it the way it appears. So cos 90 minus theta, you know, it's the same thing as so if we change it to the identity, you know, it's the same thing as cos 90 minus theta all over sine 90 minus theta, right? Good. So and cos 90 minus theta is always equals to sine theta. Do you know that? Yeah. From complementary angle. Apply complementary angle. Apply complementary angles. So and then that means that theta equals to 90 minus theta. So or cos 90 minus theta is equal to cos theta equals to sine 90 minus theta. So it always works. That's why we have that cos 30 equals to sine 60. It's one of the identity. It's called co-function identity. So and sine 90 minus theta is equals to cos theta. And then sine theta over cos theta equals to tan theta. Can you see? So therefore, it then implies that cos 90 minus theta, 90 degree minus theta, will be equal to tan theta. And tan theta, from what we have found, have we gotten tan theta? Tan theta is plus or minus 2 root 6, which is plus or minus 2 root 6. And that is the answer. So this is how to apply the identities there to solve problems. Okay, let's look at our last example in this section. Example 3. Write tan theta solely in terms of cos theta. So tan theta equals to sine theta all over cos theta, right? So we want to write it in terms of cos theta. If you see where we were proving one of our identity from Pythagoras identity, from that Pythagoras identity, we have that sine square theta plus cos square theta equals to 1, right? And that cos square theta equals to 1 minus sine square theta. If you remember that, and that cos theta, we take the square root, that will be plus or minus square root of 1 minus sine square theta. Okay, so this is what we are going to use. So we have to write solely in terms of cos theta. So if we substitute what we have there here, we have tan theta equals to plus or minus 1 minus, okay, we are writing this, I use the other way, so let's use 1 minus cos square theta all over cos theta. Okay, and since this square root cannot be simplified further, we leave the answer this way, and that is the answer.